Hello, and welcome to Module 11.3, Solving Quadratic Equations by Graphing. Our objective for today is that I can solve quadratic equations by graphing. This is going to be our first lesson on how to solve quadratic equations. We are going to teach you 5 different methods of how to solve a quadratic equation. They each have their benefits, they each have their drawbacks. Today we're going to start with graphing. So what does it mean that I'm saying to solve a quadratic equation? So what we're going to talk about today is in our vocabulary is our number of solutions. So a quadratic equation can be written in standard form of ax squared plus bx plus c is equal to 0. That is a key there. It needs to be equal to 0. Where a is not equal to 0. So our a value cannot equal 0 because if it did, our squared term would go away, and then we would just have a linear equation, not a quadratic. Graphs of quadratic functions can have no zeros, 1 0, or 2 zeros. These zeros are also known as solutions to a quadratic equation. They're also known as roots and x-intercepts. Okay, so roots, zeros, solutions, and x-intercepts are all used interchangeably. They mean the same thing in this context. So when we have no solution, what happens is our graph is shifted away from our x-axis and it's pointing away. So it could be shifted up like what you see there, or it could be down below. At no point does that graph cross your x-axis. Okay, one solution, you have exactly one point that is touching your x-axis, and that exact one point is going to be your vertex. So it could be a positive one like you see there, or it could be a negative graph like what you see in the red below. Two real solutions are going to be when the graph is opening towards the x-axis. So you see a positive graph there where we are opening up, but we've been shifted down. So you can see we have two solutions right there. You could also have a graph that opens down. And again, you would have two solutions because it's touching the x-axis at two different places. Okay, so those are all examples of no solution, no real solutions, one real solution, two real solutions. So how do we find solutions of quadratic equations by graphing? Well, first thing we want to do, because we don't have it in vertex form, so we don't have that really easy, convenient way to find our axis of symmetry in vertex, we're going to have to calculate it. So we're going to start by finding the axis of symmetry. So if you don't remember from lesson 11.1, it is the opposite of b over 2a. All right, now the opposite of b in this problem, so b is 6, so the opposite of 6 is negative 6 over 2 times 1. So we get negative 6 over 2, which simplifies to negative 3. That's the x-coordinate of my vertex, right? So now I know I'm going to put in negative 2 and negative 1, negative 4, negative 5. So I'm going to put two numbers to the left, two numbers to the right, and let's calculate and see what happens. So we're going to find the values of our table. So we're going to set up, we have negative 5 squared plus 6 times negative 5 plus 8. You'll notice, we're going to go all the way back to when we did solving systems of equations. Whenever I'm substituting in a value to an equation, I tend to put it in parentheses. And the reason why I put it in parentheses is this specific case right here. I am substituting in a negative number and it's being raised to an exponent. So I want to make sure by putting it in parentheses, that entire negative number is being squared, right? So the negative sign and the digit are both getting squared. If you put the negative sign on the outside, it would be the opposite of 5 squared, and you would get negative 25, which is not what you want in this problem. So you're going to substitute this into your calculator or do the math yourself. So 25 minus 30 is negative 5, plus 8 is a positive 3. Okay, you're going to substitute in negative 4 squared plus 6 times negative 4 plus 8. So negative 4 squared is 16. Minus 24 plus 8 is going to give you 0. Negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is 9. 9 plus negative 18 is negative 9. Plus 8 is negative 1. Negative 2 squared plus 6 times negative 2 plus 8. Negative 2 squared is 4. Minus 12 is negative 8 plus 8 is 0. Negative 1 squared plus 6 times negative 1 plus 8. Negative 1 squared is 1. Minus 6 is negative 5 plus 8 is 3. So those are our points. Negative 5, 3, negative 4, 0, negative 3, negative 1, negative 2, 0, negative 1, 3. Those are our points that we are going to now graph on our graph on the next page. And I apologize that it's not on the same side, but it is what it is with the notes that we had and the space available. So we start off, and I'll read them off to you. Our first point is at negative 5, positive 3. So we have negative left 5 and up 3. Our second point is at negative 4 and 0. Our third point is at negative 3 and negative 1. Our fourth point is at negative 2 and 0. And our fifth point is at negative 1 and 3. Right? And so now we can draw in our curve to match our graph. Now, once we have our graph plotted, we need to find the solution. So where are we intersecting the x-axis? And here's a key, they should be written as an ordered pair. So where do we cross the x-axis? We cross the x-axis in two places, right here and right here. So we have a point at negative 4, 0. We have a point at negative 2, 0. Those are my two solutions to that equation, negative 4 and negative 2. All right, let's look at our next problem. We have y equals x squared minus 4x plus 5. Let's find our axis of symmetry. So opposite of b over 2a. And so that's going to be the opposite of negative 4 is positive 4 over 2 times 1. So 4 over 2 is 2. So my vertex is going to start with a 2. So I'm going to do 2 points to the left, 2 points to the right, and let's see what we get. So 0 squared minus 4 times 0 and plus 5 is going to get me 5. Hey, look, x value is 0, y value is 5. That's your y-intercept. Remember, your c term, when we're in standard form, is your y-intercept. All right, next up, we have 1. So we're going to do 1 squared minus 4 times 1 plus 5. And we do that, we get a 2. 2 squared minus 4 times 2 plus 5 is 1. 3 squared minus 4 times 3 plus 5 is 2. And lastly, 4 squared, 16, minus 4 times 4, 16, plus 5 equals 5. So now let's plot these points on our graph. We have a point at 0 and 5. We have a point at 1 and 2. We have a point at 2 and 1. We have a point at 3 and 2. We have a point at 4 and 5. So we have our graph. Now, where are we intersecting with our x-axis? We are not. So this is no solution. So there are no solutions to this graph. Okay. All right, let's go to our next page. And when we look at this one, we have y equals negative x squared plus minus 6x minus 5. So we do opposite of b over 2a. So our b value is negative 6. So the opposite of negative 6 is positive 6 over 2 times a, negative 1. So 6 over negative 2 equals negative 3. So our x value at the vertex is negative 3. So we're going to go negative 4 and negative 5 to the left, negative 2, negative 1 to the right. So we're going to substitute in. We have the opposite of negative 5 squared minus 6 times negative 5 minus 5, and that gives us 0. We've got the opposite of negative 4 squared minus 6 times negative 4 minus 5, and that gives us 3. We have the opposite of negative 3 squared minus 6 times negative 4 minus 5, not negative 4, negative 3 minus 5. And we're going to get 4 for that. We should know the outcome of the next two already, but we're going to put them in anyways. And we get a value of 3. And the opposite of negative 1 squared minus 6 times negative 1 minus 5 is going to give us 0. Let's throw one more in just for good measure because it's easy. The opposite of 0 squared minus 6 times 0 minus 5 gives us negative 5 as our y-intercept. So let's graph these points and we can see where we're at. So we have a point at negative 5, 0. We have a point at negative 4, 3. We have a point at negative 3, 4, negative 2, 3, and negative 1, 0. And then we did graph that one more of 0 and negative 5 down there, right? So that was 3 to the right of the axis of symmetry, 1, 2, 3 to the left, puts a point right there. All right, so there's our graph. Now, where are my solutions? Well, I crossed the x-axis right there, so that ordered pair is negative 5, 0. And I cross the x-axis right there, so that ordered pair is negative 1, 0. Those are your two solutions. You need them both written, and they both must be written as an ordered pair. Solutions to a quadratic equation must be written as ordered pairs. No exceptions. Not written as an ordered pair, not going to count. And remember, x, comma, y, and it should be in parentheses. All right, last one on this page. Let's take a look at it. We're going to substitute in. We need to find our vertex, though, first. So we have the opposite of b, so negative 10, over 2 times 1. So we get negative 10 over 2, which is negative 5. So that's my starting point. We have negative 6 and negative 7 as my next 2 points to the left. Negative 4, negative 3, the next 2 points to the right. So we do negative 7 squared plus 10 times negative 7 plus 25. We get 4. We've got negative 6 squared plus 10 times negative 6 plus 25, and we get 1. We have negative 5 squared plus 10 times negative 5 plus 25, and that gives us 0. And now, the ones that we should know already, but we are going to show the math anyways. You can type them into your calculators and get your answers. You find that negative 4 squared plus 10 times negative 4 plus 25 is 1. We have negative 3 squared plus 10 times negative 3 plus 25, and we get 4. And we're going to go ahead and graph this. So I have a point at negative 7 and 4, a point at negative 6 and 1, a point at negative 5 and 0, negative 4 and 1, negative 3 and 4. All right? So we have our graph that we can now fill in. And what is my solution? It's this point right here that touches the x-axis. The point that's on the x-axis, which is your vertex, which is at negative 5, 0. All right, so you're going to flip the page. There are 4 you-try problems. I want you to do all 4 of these now on your own. You are going to graph them, and you are going to tell me how many solutions you have. All right, go ahead and do those. Check your work against mine. All right. Letter A, I didn't give you a ton of room to make a table on this one, but we're going to find our vertex, the opposite of B over 2A. So the opposite of B, that is 0 over 2 times 1, which is 0. So our vertex is at 0. 0 squared minus 16 gives me negative 16. All right. Next up, we have 1 squared is 1, minus 16 is negative 15. 2 squared is 4, minus 16 is negative 12. So we're down here still. 3 squared is 9, minus 16 is 7. So we're right there. 4 squared is 16, minus 16 is 0. 5 squared is 25. 25 minus 16 is 9. And then if we mirrored these across our y-axis, because that's where our axis of symmetry is, we're going to be able to find our points on the negative portion of this graph. So we now just draw our curve in. We've shifted it 16 units down from the origin. We did not compress it or stretch it at all. So now we're looking for where is it crossing the x-axis. So it crosses there at negative 4, 0. And it crosses right there at 4, 0. So the two solutions for this quadratic equation are negative 4 and 4. And as you look at that equation, you might start doing some deductive reasoning about other ways that we can use to solve a quadratic equation, other avenues we can approach. But that's a lesson for another day. All right, letter B. We've got a equation that's in vertex form. X minus 2, the quantity squared, is equal to 0. So when we go ahead and graph that, well, what's happening to my vertex? We're shifting right 2 units. And am I shifting it up or down at all? No, I'm not. So I just moved my vertex right there. So now let's look at these. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared is 4. 5 minus 2 is 3. 3 squared is 9. And I'm going to remember that I have an axis of symmetry that I can work with. My dashed line didn't work very well. That I can reflect across. So if it's at, 5 would have been 1, 2, 3 units to the right. So I go 1, 2, 3 units to the left. The point at 4, 4 is 2 to the right. So I go 2 to the left. The point at 3, 1 is 1 away. So I go 1 to the left. And now I have my line nicely graphed. So where is my solution? It's right there at the origin, 2, comma, 0. Right? 2, comma, 0 is my solution for this problem. Letter C is a little bit tricky because we have a value off to the right-hand side there, right? So remember, I said this had to be an equation equal to 0. So we're going to add 25 to both sides so that we can get it to be equal to 0. And we get x squared is equal to 0. So this is our base graph, our parent function. We should know by now easily how to graph this. And we could practically do it in our sleep because we know our perfect squares, especially when it's 1, 2, and 3 that we're working with. So what is my solution? Our solution is the vertex, which is also the origin, and it is 0, comma, 0. That is your solution for that quadratic equation. The last one, 3x squared plus 6 is equal to 0. So we need to find the vertex, so the opposite of b, so the opposite of 0 over 2 times 3. So 0 over 6, which is 0. So I know my vertex is going to be at 0. Now I need to substitute it in. 0 squared is 0, times 3 is 0, plus 6 is 6. So we have our vertex at 0 and 6. And we need to go 1 to the right. So 1 squared is 1, times 3 is 3. 3 plus 6 is 9. And we're going to mirror that to the left as well. Because it's positive, I know it's opening up. I don't have any more room on this graph this grid to graph. So unfortunately, we're only going to get 3 of our points in, not 5 of them, like I normally like to do. But this is a product of the problem that I gave you. What do I see about this? Is my graph going to come anywhere close to touching the x-axis? No, it's going to infinity in a positive direction. It's been shifted up and away from our origin. So this is going to be no solution. So as we zoom out and look at some of these formulas, right? If the formula, or if it opens up and it's shifted down, like letter A was, it's going to be 2 solutions. If it's opening up and it's shifted up, like letter D is, it's going to be no solution. So as we start working with these problems and you can start seeing how the equation is changing, you're going to be able to see a little bit how these values are going to be affected by the terms in the equation. All right, our last one here, we've got approximating square roots of quadratic functions. In 1941, the Boston Red Sox, Ted Williams, hit the highest pop fly ever recorded. Assuming an initial velocity of 58 meters per second and an initial height of 1 meter, the function h equals negative 4.9 t squared plus 58t plus 1 models the height of the baseball h in meters after t seconds. If it falls to the ground, approximately how long will the ball be in the air? So we have the graph right over here that we're going to look at. And we're not hitting places exactly, but we do have some approximations that we can work with, right? Because as I look at this, it doesn't quite seem like it's hitting exactly at 12. And 0 doesn't quite seem like it's hitting 0 either. So let's kind of work with this and see. And it's especially true given those grid lines vertically are a scale of 20 feet. And the horizontal grid lines are a scale of 2 feet, or 2 seconds. So, if this one whole gap there is 2 seconds, if we're just a fraction off, that we can see how that can affect it. So we have some points calculated for us already. We have 11.7 seconds. We've got 12.2 seconds, 12.3 seconds. The way we're going to do this, you are going to substitute those times into that equation. And you will need a calculator for this. And you are going to need to do some rounding potentially on these problems. So when you substitute in 11.8, what do you get? You're going to get 3.124. Okay, so it's 3.124 feet off the ground at 11.8 seconds. What about at 11.9 seconds? Well, you substitute that in. Negative 4.9 times 11.9 squared plus 58 times 11.9 plus 1, and you're going to get negative 2.689 feet. We've gone from above ground to below ground. Our height has changed. So our time is going to be 11.8 to 11.9 seconds. It's going to be in between those two times when the ball hits the ground. But let's finish it out. Let's do the 12 squared. So negative 4.9 times 144 plus 58 times 12 plus 1, and we're going to get negative 8.6 feet. And the last one, 12.1, negative 4.9 squared, negative 4.9 times 12.1 squared plus 58 times 12.1 plus 1 gives me a negative 14.609. So this is going to be the first indication that graphing has some limitations. And the graphing method is great if you have technology doing the graphing for you. If you have a graphing calculator or a program that you can graph with online, solving by graphing is a great method to use. However, if you don't have access to a grid paper or you don't have access to digital technology to do the graphing for you, if it's something that's not a nice, neat number like this would be, you're going to have problems finding your solutions. So when you're looking at it, like I said with this one, is the grid hitting, is the line hitting exactly in the corner? Do we have a point exactly at 12? We don't in this case. So we need to be able to find some other methods. So graphing is a good method for finding numbers of solutions, and it's a great method when you have technology involved and you're able to work with the technology, but it does require a lot of precision. And so that's where its shortfall is. It requires precision and it requires time. It's time intense. So that is the end of our notes for Module 11.3, and this is going to conclude our graphing portion of solving quadratic equations. So this is going to be a good breaking point before we find some other methods to solve a quadratic equation. All right, so if you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.